Well, hello everybody. Here's what you missed the other day. We went ahead and answered questions over piecewise functions. That was our day 10 material. We did take a quiz over the homework, so over the piecewise, so we'll have to get that made up with you. And then we graphed what we call our absolute value functions and our parabolas. A lot of calculator work today, so make sure that you're okay keeping up with me with your calculator. If you need to hit pause and then run something through to make sure that you know how to do that, then we'll do that also. So feel free to use the pause button, the stop button at any point. But you should have in front of you your class notes that say day 11 on there. It should say day 11. And it should look like this. So hang with me, and then we'll go from here. Like I said, it's a lot easier than what we did the other day. Look at your first graph there that says y equal f of x equal x squared. Hey, the reason I wrote it that way, y equal and f of x equal mean the exact same thing. So there's no difference if you see one compared to the other. If you will, come down into your chart into box number 4 under the x-axis and put a 0. That's going to be the key today for you guys. I got to show you what's called the main number. It's the x-coordinate of the vertex. And then I'll expand on it next class. But if you will, put a 0 down in box number 4 there. And then here's what we're going to do every time. We're going to generate 7 points so that we can graph this thing. So from this 0, I'm going to add 1, add 1, add 1. And from that 0, I'm going to subtract 1, subtract 1, subtract 1. Now the rest of this is just calculator stuff or brain stuff. I'm going to plug these x values in for right here, that x value right there. So I'm going to go 3 squared and get 9. I'm going to go 2 squared and get 4. I'm going to go 1 squared and get 1. I'm going to go 0 squared and get 0. I'm going to go negative 1 squared and get 1. I'm going to get negative 2 squared is going to be 4. Hey, now while I'm here, if you type this in some of your calculators, it's going to lie to you. It's going to take the opposite of 2 squared. You want that. You're going to have to put those in parentheses. So most of you, when you're taking something to a power, we need to put that in parentheses. And then negative 3 times negative 3 is going to be positive 9. This is going to make what we call the parent parabola. It's going to make what we call the parent parabola. All parabolas are generated from this parabola here. So I'm going to go over 3 and up 9. I'm going to go over 2 and up 4. Over 1 and up 1. Over 0 and up 0. Negative 1, 1. Negative 2, 4. And negative 3, 9. Now a parabola has curvature to it. So here's what my parabola is going to look like. It's going to be a smooth curve that looks like that. Put the arrows on the end to show the world that it goes up forever. So the name of this is a parabola. Not a parabola, a parabola. The domain of this, you're going to like this, the domain of every parabola is negative infinity to infinity. So that part's pretty nice. Now the range of this thing says, hey, what y values are being used? Well, the littlest y value that I'm using is 0. And then they're going up from there. So my range is going to be from 0 to infinity. Notice the infinity gets the parenthesis, the 0 gets the bracket. The next parent graph that I'd like to show you is called the absolute value graph. No fancy name. Absolute value. Okay. Once again, if you will, come down to your fourth box there. 1, 2, 3, 4, 5, 6, 7, 8. Let's put an XY there and there. And in that fourth box, put a 0 again. It's not always 0. I will show you how to get that here in just a heartbeat. And then once again, guys, I'm going to add 1, add 1, add 1, subtract 1, subtract 1, subtract 1. And then remember, on absolute value, I'm going to plug in the number, and then if it's negative, I'm going to make it positive because it means distance from 0. So when I plug in 3, I get the absolute value of 3, which is 3. Absolute value of 2 is 2. Absolute value of 1 is 1. The absolute value of 0 is 0. Absolute value of negative 1 is 1. Absolute value of negative 2 is 2. Absolute value of negative 3 is 3. When we graph these, it's going to make a V. So I'm going to go over 3, up 3, over 2, up 2, over 1, up 1, 0, 0, negative 1, 1, negative 2, 2, negative 3, 3. I'm going to put my straight edge down and draw my V-graph. Missed it by a little bit. Missed it worse. Okay. You're going to like absolute value graphs also. The domain of every absolute value graph that we're going to work with, negative infinity to infinity, which just means, hey, you can plug in any number in the whole wide world that you want. The range in this case, the littlest y value that I use is 0 again, and it goes up forever. So 0 to infinity. Hey, I'm going to point out a couple of things that I won't point out on the rest of them. These have what we call a line of symmetry. There's a line of symmetry that goes right down the middle of both of these. This line of symmetry means this. If there's a dot here, there's also a dot there. If there's a dot 2 units this way, there's a dot 2 units this way. If there's a dot 1 unit this way, there's a dot 1 unit this way. It also means this. If you do a good job of picking the right middle number, that your 2 outside numbers will be the same, your 2 next numbers will be the same, and these 2 numbers will be the same. So it's a check. Check it out here also. 3s, 2s, and 1s. So it's kind of a check with symmetry. The key thing though, guys, is getting that number right there. So here goes my next one. Hey, notice I did not draw you an XY chart on this one. So if you will, draw yourself your own XY chart real fast. And we need room for 7 numbers. So I'm going to come in here and put 1, 2, 3, 4, 5, 6 lines. That'll give me 1, 2, 3, 4, 5, 6, 7 blanks. Now here comes the hardest part of the day. If you can do this, graphing these is pretty easy. Look at this x plus 2. What I need you to do is take x plus 2 and set that equal to 0. If you do that, you subtract 2 from both sides, you get x equal negative 2. That's going to be the number that goes into your x spot right there. So I took x plus 2 and I set that equal to 0, and I got negative 2. That's what you do to get the vertex number, the x coordinate of the vertex. And then I'm going to add 1, add 1, add 1, subtract 1, subtract 1, subtract 1. Hey, now, I'm hoping that you can do a lot of this in your head. It's an absolute value graph, so I know when we're done, it should look like a V. So here goes. Let's try this in your head. You can also use your calculator if you want, but 1 plus 2 is 3, and the absolute value of 3 is 3. 0 plus 2 is 2. The absolute value of 2 is 2. Negative 1 plus 2 is 1. The absolute value of 1 is 1. Negative 2 plus 2 is 0. The absolute value of 0 is 0. Negative 3 plus 2 is negative 1. But the absolute value of negative 1 is positive 1. Negative 4 plus 2 is negative 2, but the absolute value of negative 2 is 2. And negative 5 plus 2 is negative 3, but the absolute value of negative 3 is 3. If you want to use your calculator, guys, you'll do this. Negative 5 plus 2 equal, and then you'll look at it. If it's negative, hit your negative button or clear it and type in the non-negative number, or multiply it by negative 1. Hey, so like I said, I know this graph should be a V. So let's plot them now. I'm going to go over 1 and up 3. I'm going to go over 0 and up 2. I've got negative 1, 1. I've got negative 2, 0. I've got negative 3, 1. Negative 4, 2. And negative 5, 3. So it looks like it's going to form a V again. Put your straight edge down. Connect those dots. I keep missing my dots by just a little bit. There, I got that one. Hey, so once again, guys, you should see symmetry. In this case, right there. Your line of symmetry always goes through that little point called the vertex. Your domain, negative infinity to infinity. Your range, again, in this case, the littlest number is 0 on the y's, so 0 to infinity. That's going to change here in just a minute. I'll show you what happens if your parabola or your absolute value gets moved off the x-axis. I had to make some room to fit my next xy chart, so if you will, make an xy chart there for your number 4. Hopefully you have room off to the side. And then I'm going to put 1, 2, 3, 4, 5, 6 lines in it again. To get your main point, I'm going to take x minus 3, the piece inside the parentheses, or the piece inside the absolute value, and set that equal to 0. Hey, notice I did not even worry about that negative 4 yet. I will in a little bit. I'm just trying to get the main number that goes right there. So x minus 3 equals 0. Add 3 to both sides, so it tells me my main number, my x-coordinate of the vertex, is going to be 3. So I only set the piece inside the absolute value, in this case, equal to 0. Don't worry about the negative 4. We'll use it in a minute. And then I'm going to add 1, add 1, add 1, subtract 1, subtract 1, subtract 1. If you wanted to minus 1, minus 1, minus 1, and add 1, add 1, add 1, that's okay too. That part doesn't matter. So here goes. Plug in your 6 first. 6 minus 3 is 3. Now I got to subtract it to 4. So 3 minus 4 is negative 1. 5 minus 3 is 2. Absolute value of 2 is 2. 2 minus 4 is negative 2. 4 minus 3 is 1. 1 minus 4 is negative 3. 3 minus 3 is 0. 0 minus 4 is negative 4. Now be careful. 2 minus 3 is negative 1. But the absolute value of negative 1 is 1. 1 minus 4 is negative 3. 1 minus 3 is negative 2. But the absolute value of negative 2 is 2. 2 minus 4 is negative 2. And then if I plug in a 0, 0 minus 3 is negative 3. But the absolute value of negative 3 is 3. 3 minus 4 is negative 1. Remember, if you've done a good job, these are the same, these are the same, these are the same. Symmetry. And once again, absolute value, so I know my graph should look like a V when I'm all done. So let's plot the points. I've got 6, negative 1. I got 5, negative 2. I got 4, negative 3. I got 3, negative 4. I got 2, negative 3. 1, negative 2. And 0, 1. Oh, 0, -1. I lost my negative there. Okay, so it looks like it's going to be a V again, guys. So put your card down. Connect those dots. Put arrows on the ends. Let's keep the domain easy. For every parabola that we do and every absolute value we do, it's -infinity to infinity. Now let's get the range this time. What's the littlest y value that we're using? Well, if I look down here, the littlest y value I'm using is right there at -4. And it's going up. So bracket -4 to infinity. Okay. Now the next 4 I'm going to do, guys, I'm just going to make them a little bit harder. But that's the concept. So here's your number 5. Once again, set up a little XY chart for you. And I'm going to put 6 lines in here. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. I need my main number right there. I need my main number right there. Before I say what the main number is, can you tell me what it's going to be? My main number is going to be a 2. I need to take x minus 2 and set it equal to 0. Add 2 to both sides, so there's my main number right there. I'm going to add 1, add 1, add 1, subtract 1, subtract 1, subtract 1. There will always be 7 numbers in your chart. And then try to do this in your head, but if not, that's okay. You'll go parenthesis 5 minus 2, close your parentheses squared, and you should get a 9 in this case. So that's going to be a 9. I'm going to speed this process up a little, guys. 4 minus 2 is 2. 2 squared is 4. 3 minus 2 is 1. 1 squared is 1. 2 minus 2 is 0. 0 squared is 0. 1 minus 2 is -1. -1 squared is +1. 0 minus 2 is -2. -2 times -2 is 4. And that becomes a 9. If you've done a good job, look at that. Hey, now, check out your graph before you draw it. It's back to a parabola, so I should see something with some curvature in it. So over 5 up 9. Over 4 up 4. Over 3 up 1. Over 2 up 0. I got 1, 1. I got 0, 4. And I got -1, 9. Connect those dots with a smooth curve, not a V. If you see it, it does have that symmetry in there. It's right there. So dot, dot, there's a dot, there's a dot. So the symmetry is working for us. I'll do the domain for you, -infinity to infinity. Hey, how about the range? Go find the littlest y value that you're using, 0, and it's opening up. So bracket 0 to infinity. Now I'm just going to try to make the calculator part just a little bit harder, but the concept's down. I'll slow down a little bit on this one in case you're typing it into your calculator. I like to do all these in my head, of course. So 1, 2, 3, 4, 5, 6 lines. Can you tell me the main number that's going to go right there? And it's going to be -3. The reason being, x plus 3 equals 0. I'm going to subtract 3 from both sides, so there's my main number. Hey, notice once again, I did not care about that -5. I will when I start using it, though. So I'm going to add 1 to -3, so I'm going to get -2, -1, 0, negative 4, negative 5, negative 6. Now, if you're going to use your calculator this time, and it's a parabola, just type in what you'll see. You'll go parenthesis, 0 plus 3, close your parenthesis, squared, minus 5 equal. And if you do that correctly, guys, you should get 4. If you're going to use your calculator, and you're using a negative 1, you'll go parenthesis, negative 1 plus 3, close your parenthesis, squared, minus 5. So you should get 4 minus 5 is negative 1. This value becomes negative 4. This value is negative 5. Then I've got negative 4, negative 1, and 4. I cheated. I already had the answers these typed out. So something I should see again, it's a squared, so I should see a parabola. So here goes. I'm going to go 0, 4, negative 1, negative 1, negative 2, negative 4, negative 3, negative 5, negative 4, negative 4, negative 5, negative 1, and negative 6, 4. If you ever get a line looking thing, then you messed up your numbers here. A smooth curve, of course. Arrows on the ends. And I missed a dot again. I'm on a different computer, so that's my excuse. Hey, the domain and range. The domain, negative infinity to infinity. You can't miss that. The range, the smallest y value I'm using is right there at negative 5. So bracket, negative 5, up. Bracket, negative 5, up. Hey, then it looks like I just got 2 more with you. Looks like the video is going to be about a total of 30 minutes, so that's not bad. Here's my number 7. It's another absolute value graph. Now this one's harder because it just doesn't type nicely into your calculator. So here's my XY chart again. 6 lines, 1, 2, 3, 4, 5, 6. And my main number is going to go right there. To get my main number, I'm going to go x minus 1 equals 0. Hey, notice I did not mess with that 2 or that negative 5. All I care about is just what's in the parentheses. So that's a 1. And then I'm going to add 1, add 1, add 1, subtract 1, subtract 1, subtract 1. Now this one's harder. If you're going to use your calculator with this one, here's what you need to do. Let's pick on the 4. You're going to go 4 minus 1 equal. And you're going to see a 3. Since that's already positive, don't change it. And then you're going to go times 2 minus 5. So in this case, you should get 1. Let me pick on another one real fast. If you're going to do a 3, you're going to go 3 minus 1 equal first, and you're going to get a 2. And then, since it's already positive, times it by 2 minus 5 to get negative 1. If you do a 2, you should get negative 3. And when you do a 1, you should get negative 5. Now let me show you what it looks like if there's a negative number shows up on your calculator. You're going to go 0 minus 1 equal, and your calculator is showing you a negative 1. You will change this to a positive. So clear it and type in a 1, or hit negative 1 or times by negative 1, but what might be easiest for you is clear it and type in a 1. So you just got a 1 sitting in your calculator now. And then go times 2 minus 5 equal. And you should get negative 3. Then if you do that, you should get negative 1 and 1. So absolute values are a little bit harder in your calculator. To plot it, over 4 and up 1, 3, negative 1, 2, negative 3, 1, negative 5, 0, negative 3, negative 1, negative 1, and negative 2, 1. Hey, if you've done it right, I should see dots on the same lines. And I do. So I know we're setting pretty good. It's absolute value, so I should see a V again. Put my arrows at the ends. The domain, that's the easy part. Negative infinity to infinity. The range in this case, the littlest y value that I'm using is looking like a negative 5, and it's opening up. So I've got negative 5 to infinity. Hey, if you ever get one, guys, that's opening like that, let's say positive 5 was your biggest value, then your range would look like negative infinity to 5. The reason that is because it's opening down. If it's opening down, this goes first. So, doesn't look like I put one like that on this sheet. I might have on the homework. We'll see. Okay. Hey, then my number 8, my last one for you. This one's really a little bit easier because you can use your calculator to get all your numbers. So here's my little XY chart again. 1, 2, 3, 4, 5, 6. I need my main number right there. Can you tell me what my main number is going to be? It's going to be negative 5. I got that by just going x plus 5 equals 0. Let me add 1, add 1, add 1, subtract 1, subtract 1, subtract 1. Hey, now let me show you how to run this one through your calculator. You're going to type in exactly what you see. So you're going to go 2 times, then you see a parenthesis, so I'm going to type a parenthesis. Then I'm going to go negative 2 plus 5, close your parentheses, squared, minus 7 equal. On a parabola, just type in exactly what you see. If you do that correctly, guys, you should get 11. And then now when I'm going to do negative 3, in place of the negative 2 comes a negative 3. So I'm going to go 2 times parenthesis, negative 3 plus 5, quantity squared, minus 7 equal, and you should get negative 3. You could pause the video and try these next ones, but you should be getting negative 5, negative 7, negative 5, negative 3, and 11. It's a parabola, so I should see some curvature to it. So I've got negative 2, 11, off my chart a little bit. I've got negative 3, negative 3. I've got negative 4, negative 5. I've got negative 5, negative 7. Negative 6, negative 5. Negative 7, negative 3. And then I got negative 8 way up here again. If you just look at these dots, it looks like it should be a V. That's why these dots are important. That's where I get my curvature at. Kind of a skinny parabola. Next time we'll call that stretched. So my domain, negative infinity to infinity. The littlest y value that you're seeing, way down here at negative 7. So my range, negative 7 to infinity. There goes our day 11 material. Try to get your homework rolling. If you have any questions, buzz in and see me. Good luck.